Hello and welcome. In this video, we'll discuss about relations. So before we go into the concept of relation, we shall revisit some of the basic concepts that we have already discussed. Concepts like sets and subsets. So we all know that a set is a set is a collection of set is a collection of well-defined objects. Well-defined objects. For example, A equals 1, 2, 3. B equals red, green, blue, red, green, blue. C equals, I can write A comma B comma C. This we can write many number of sets. And what is a subset? If there are two sets, let's say we have two sets P and Q. If all the elements of Q is present in P, then we can say Q is a subset of P. Q is a subset of P. We'll take an example to understand this. If I have P is equal to, let's say, 5, 6, 7, and 8, and Q is equal to 6 and 7. So here Q can be said as a subset of P because the elements 6 and 7 both are present in P. So Q is a part of P. If any set is a part of another set, then such set is called the subset of the original set. If I take R is equal to, let's say, 5 comma 9, then I cannot say R is a part of P because all the elements of R is not present in P, because even the 5 is present, 9 is not present in P, so R is not a subset of P. And another topic that I want to discuss here is the Cartesian product, because this helps us to develop the definition for relations, the Cartesian product. So if I have two sets, let's say we have A is equal to 1 comma 2 comma 3 and B equals A comma B, then the Cartesian product is obtained by pairing every element of A with every element of B. So I'll take the first element of A and I'll pair this with every element of B. So I'll get 1 comma A, 1 comma B. I'll do the same for all the other elements of A. 2 comma A, 2 comma B, and 3 comma A, 3 comma B. So this is my Cartesian product. So with the help of this Cartesian product, we can actually develop the definition for a relation. So a relation R, a relation R from a non-empty set, from a non-empty set A to another non-empty set B is actually a subset is actually a subset of A cross B. So here, if I write R equals 1 comma A, 2 comma A, and 3 comma B, then this is also a relation. Another way of representing this relation is we can represent the elements of A and B inside these circles. Like this is my set A This is my set B. This is 1, 2, 3, and we have A, B, C. I think only we have A and B. Right, B over here. So according to this relation, A to B are 1 is paired with A, 2 is paired with A as well, and 3 is B. So this is one of the representation of a relation. There is another simple definition for a relation. A relation, a relation is actually relation is a relation is a rule or condition or a formula which relates the elements of relates the elements of two sets. So elements of two sets, any two sets, we'll take A and B. For example, say if I have A is equal to 5, 3, 6 and B is equal to 7, 1, 4. So I can develop a relation between these two sets like this. R is equal to A comma B, where A is greater than B. Where I'll take A from set A and B from set B. So this is also a definition for relation. Let's see how many ordered pairs we'll get from this. So what this relation is saying is we have to take first element from set A and the second element B from set B such that the element we pick from set A should be greater than the element we pick from set B. So if I take 5, I'll pair it with, I can pair it with 1. I cannot pair it with 7 because 5 is not greater than 7. So I can pair it with 1. Similarly, I can pair it with 5 with 4. Then I'll go to the next element of here, which is 3. 3 can be paired with 1 because 3 is greater than 1. 3 cannot be paired with 7 or 4. Finally, we have 6. 6 can be paired with 1 and 6 can be paired with 4. So this is also the definition of relations, and we can observe here whatever we write. So whatever we write here, this will be a subset of A cross B. A subset of A cross B. So one definition is a relation is always a subset of A cross B, or it can be a rule, condition, or formula which relates two sets A and B. Now we'll jump on to the last topic of this video, which is which is the number of the number of the number of relations one can generate from two sets A and B with A having P elements and B having Q elements. That is, number of elements in A is P and number of elements in B is Q. So it is pretty straightforward because we know that a relation is a relation is a relation is actually is a subset of is a subset of A cross B. So in order to find how many number of relations that can be generated from A into B, is we just need to find the number of subsets we can generate from A cross B. So the number of relations from A to B is actually equal to number of subsets of A cross B, number of subsets that we can generate from A cross B, because every subset is a relation. So the total number of subsets we can generate from A cross B is equal to the total number of relations that can be generated from A to B. So let us answer few questions here. So we know that here number of elements in A is P and number of elements in B is Q. So number of relations from A to B is equal to 2 power P into Q. This we already discussed, because 2 power PQ is the number of subsets that can be generated. Similarly, the number of relations from B to A is 2 power Q into P. The number of relations that can be generated from A to A is 2 power P into P, or we can write this as 2 power P square. Number of relations that can be generated from B to B is 2 power Q into Q, or 2 power Q square. So with this we can solve some problems. Let's see some problems in the next video. Thank you.